face.
Oh, I just noticed how big my forehead is getting now too.
Yeah,
I feel like
it's not a forehead. It's not a forehead.
No, what is it?
Forehead is that.
Yeah.
You've got an 8 head about like myself.
Yeah, my forehead used to end right about here, and now it's creeping all the way back too. So,
yeah. Isn't that why they call it a forehead? Because you can put your 4 fingers
all
up there.
4 fingers.
Is that what it is?
Yeah. Yeah. You don't have a forehead.
You're listening to the Foundry Talk podcast with your hosts, Nate McClain and Perry Merritt. Take it away, boys.
Well, welcome back. My name is Perry. As always, Nate McClain, my partner, is with us. This is episode 11. I can't believe that we have made it this far. Found 11 people that would be willing to talk to us. Today we have with us Bryan Davis. He is the National Sales Manager for Remelt Sources out of Cleveland, Ohio. And Bryan, before I let you say anything, I want to ask a question. I've noticed on our statistics that somebody in my old hometown of Santa Ana, California, is listening to our podcast. So if you are that person, I would love to hear from you. Perry at foundrytalk.com. Just let me know who you are. All right, Bryan, to you. Why don't you tell us a little bit about yourself? Tell us about Remelt Sources, and we'll just kind of get into this thing.
Sure. No, thanks for inviting me. Thanks for having me. It was first one of these I've ever been on, and was kind of flattered to have been to have received the invite. So we'll start off with that. Bryan Davis, Remelt Sources. I've been here for over 18 years. In a prior life, I came from a company, Rolled Alloys, that sold wrought, Perry, plate, bar, and sheet, and it was a service center. So it did all the plasma cutting, laser, water jet, all the shearing and saw cutting. And it dealt with fabricators, machine shops, forge shops, things like that. And Rolled Alloys was actually one of my customers, or Remelt Sources was actually one of my customers. So I sold plate, sheet, bar to my company, to Remelt Sources now. And that's kind of how I networked into this gig. A lot of the same alloys, a lot of similar alloys, but just different worlds, wrought versus cast. So been here 18 years, moved up from sales to sales manager, and I deal primarily with just Foundry products. We touched on it earlier. You asked about our wrought division, much smaller segment of our business, but it exists, and we have a whole separate product manager that handles all of that. But I focus primarily on the Foundry ingot, cast bar.
Okay. Well, you mentioned to us something just now. I'd asked you earlier, where do you source your materials? And you mentioned that you sold material to Remelt. Is it you sold that as a fabricator? You sold scrap to them, or how does that work?
Well, it was a special program that they were involved in. I'm not sure they're involved in it to this day, and they needed some basically blanks for somebody to cut out materials from. So I just sold them basically 48 by 48 stock sheets of really thin aerospace foil grade materials. And I had no idea what Remelt Sources even did, to be truthful. The name's kind of doesn't really tell you a lot about it. And I remember asking we had at that time an outside sales manager who called on all of the region, and Remelt Sources was one of his. He would call in Remelt Sources, and his name was Gary. And I remember calling Gary. I go, Gary, what do these guys even do? They're asking about all this, Nickel X sheet and Waspaloy sheet, all this really thin aerospace materials. And he goes, Remelt Sources. He goes, yeah, they make golf club heads. And that was, couldn't be further from the truth of what actually happens at Remelt Sources, but that was his understanding at the time. And I think he knew that golf club heads were investment cast, and Remelt Sources was involved with the investment casting industry. How, he didn't know, but he just knew that was the connection. So that was my introductory to Remelt Sources, where they make golf club heads.
So did they have anything to do with golf club heads?
So if you go back in time, really before my time there, yeah, we sold golf club heads used to be manufactured in the United States. It's all since been kind of offshore. So the bulk of it's produced in China. But the foundries here in the States, some of them were making golf club heads. And Remelt Sources would supply alloy to those foundries. But unfortunately, those jobs are just overseas now.
Sure, that makes sense. I know that a lot of investment foundries that they've made putters and that sort of thing. I don't know if there's a domestic putter manufacturer for Ping or Callaway or any of those Titleist or any of those companies are in the U.S. today. I don't know.
I'm not aware of them if they are. Yeah, I think a lot of that went overseas to China. I know there's a foundry in the States that has the capabilities of doing it if that work were to ever come back, or if for some reason they wanted to try to pull it back. But I don't believe they actively are casting those.
Well, and the reason I ask, the putter that I actually have in my golf bag today is a putter that was actually manufactured in Oklahoma, in my hometown in Blackwell.
Oh, wow.
At the time, OICC, they had a company that they were making putters for. At the time, Kerry Meister was the one that was running the foundry.
Yeah.
And he's since retired. And they had, I don't think the customer ever paid for the putters or whatever, so they gave them away. I mean, they had the shafts, the grips, everything on them already. And the putter that I have that I still use to this day it was manufactured in Blackwell, Oklahoma at OICC, which was pretty cool.
Nice. Yeah.
Yeah, pretty fun. It's almost like a carbon copy of a Ping, a traditional Ping putter that you would see, but it's a knockoff of some sort. So it works great.
It works
they just
well.
need somebody else that can putt it besides me.
There you go. I guess that's the important thing right there. Does the ball go in the hole when you hit it? So,
well, if somebody else would use the putter, it would probably go in the hole.
Nate, I've heard you've got quite the prowess on the golf course. So
somebody's been lying to you, Barry. That is not true at all. But I enjoy playing golf. I enjoy it a lot. So some of the alloys that you manufacture at Remelt is I mean the gamut is pretty big. I mean from cobalt based alloys to nickel based alloys, nickel coppers, stainless, tool steels, low carbon steels, low alloy steels.
Sure.
Is there any one particular thing that you guys feel like it's your kind of your niche, the thing that you guys really thrive or hang your hat on?
Yeah, so a couple of things really. I would say probably cobalt base. We produce in our facility in South Carolina. That's the VOD shop. Perry, you were asking about that. So that's where we produce all of our VOD refined product, and we have the ability to do continuous cast bar in South Carolina as well. And I believe that's our specialty. So high quality, critical cobalt based alloys. After that would be, kind of stainless grade. So we do a lot of high volume, 300 series, 17.4s, 15.5s, your CA6NM. We produce a lot of that at our facility in Homer City. We have a partnership with a facility in Homer City, Pennsylvania. And we distribute all of the alloy that they produce for the investment casting industry. That's large heats, it's AOD refined, and it's a high quality ingot at a pretty competitive price. So a lot of the product you see from us is going to be produced out of that facility in Homer City.
Okay.
So
Interesting. So when it comes to refinement like that and AOD for the listeners because the guys, a lot of the vast majority of most foundries in the U.S. they're iron based foundries, so they don't even refinement. I mean, they want the carbon. They don't want you to remove it with a AOD refinement. Can you explain to the listener what is AOD refinement and why is it important?
So, well, AOD is argon oxygen decarburization. A little bit out of my depths here, but the story I've been told is AOD was really invented to make low cost stainless steels that require low carbon. So your 304Ls, your 316Ls, your L grade stainlesses, because they can start with really high or really low cost chrome units. It'd be the high carbon ferrochrome. It's pretty inexpensive to buy, but it might have 5% or 7% carbon. In the AOD, they can blow that right out and salvage the chrome units, which is what they're after, to make low cost stainless steels. So we can buy low carbon ferrochrome, or we can buy high carbon ferrochrome. Low carbon's much more expensive than the high carbon. So the advantage of the AOD is we can start with the really low cost, high carbon chrome units and just get rid of the carbon. So and then we can still achieve the L grade stainlesses, the O3 max stainless steels.
Mm-hmm.
All right,
Yeah.
So helping an idiot out here. You can really straighten me out here. I always thought that stainless was a high carbon product. It sounds like that's not the case at all, right? Is that
correct?
So what makes stainless as opposed to just a mild steel that I go to Home Depot and buy?
So I believe it's the chrome. So the chrome content is really what makes the stainless steel stainless, right? So stainless just means it's not going to rust, or it's going to not rust as quickly, right? I think anything's going to rust over time. But the stainless steels with the carbon or the chromes they're going to withstand.
So it's a iron and chrome alloy that makes it stainless.
Yeah, chrome. Yeah, correct. It's going to be
Is
the
it chromium
chrome.
or is it chrome or
Yeah, the chromium.
chromium? All right.
Yeah. And so that's like with the 316, 304, right? So you got your 316's got your roughly 9% nickel, 18% chrome. That's the same as 304. The only difference is the moly. So I believe that they add a little bit of moly and they're going to get that much more, that much, it's going to be that much more stainless if you want. So it's not going to corrode as much.
Yep. And that's correct. Yeah, the moly in 316 is higher. I think it's in the 2 to 3% range. Versus 304, it's more like 0.75% moly. So,
and that's a max. Really, there's no intentional
right
moly for 304. So as long as it falls below 0.5% or whatever that limit is, it's going to be considered 304.
Yep. And then you run into the other alloys, 316Ls or the CF3Ms, so to speak, that have lower carbon than say a CF8M, which is a 316, is typically the case. So Perry, when you're thinking about 316, you're talking about like a 0.08 carbon, which is very low. But 316L, which is CF3M, is like max of 0.03. So the carbon is even lower there again. So starting off with it's hard to meet that spec if the carbon if you don't get the right metal. And when you're melting steels and stainless steels like that, you've got to keep the carbon low enough because you'll pick up some residual carbon. And as you bring revert or remelt gates and risers back into the melt, if you pick up carbons along the way because of some other alloys that you might be pouring, well, because it will pick up carbon from the residual material left in the induction furnace, the lining that kind of hangs on there, so you can contaminate in that regard. So a lot of times you got to have wash heats and stuff like that, or you've got to use more virgin material that you would buy from a supplier like Remelt. So those are some of the things you got to really pay attention to when you're dealing with your metallurgy and making sure that you're not contaminating your existing melt. Because we don't have AOD refinement in the foundry, so we depend a lot of times we depend on the vendors to provide us with the right material so we can blend and make sure that we're checking our chemistries with the spectrometer at the facility so that we're staying within spec for the customer's requirements.
So once the carbon's there, you guys have no ability to remove the carbon. So once it's there, it's there. So the lower the carbon that I can give you guys, the more room you guys have for pickup along the way. The more life you guys should get out of your revert as well.
Yep.
But you're not adding carbon, right, Dave? I mean, are you intentionally adding carbon? You're not doing that.
It depends on the alloy. So if it's iron, a lot of times you do have to add carbon raiser, because a lot of times you have to get the carbon somehow. So in the event of that you're melting a gray iron or a ductile base iron before you treat it with ferromagnesium, then you're going to have a lower carbon than you'd like, but you have to get the carbon somehow. And the easiest way, but the most expensive way to get carbon is using pig iron. It's high in carbon. It's good. It's pure in its purest form, but it's also expensive. It's expensive to transport, that sort of thing. So, and I don't even think I'm not aware of a domestic source for pig iron. And somebody will email me and tell me I'm crazy that there is, but I'm pretty sure that all comes from overseas and it's imported. But if you need to, you can use carbon razor, different types of carbon razors, different grades of carbon razor, things of that nature. So we do add carbon for iron purposes, like at Kansas Castings. We use carbon razor quite often because then you can use kind of like what Brian's talking about when they try to buy alloys that have scrap material that have the properties that they need for a particular casting purposes. Well, if I can buy something that has higher carbon in it, then that's what I'll buy. So it just depends on if it's structural steel or what type of steel you can get your hands on. If it's a WCB, you're still not going to have very much carbon. And when you need to get the carbon high enough for iron purposes, for the iron foundry guys, they're going to look for something that's got high carbon. But when you're pouring ductile iron, you got to make sure that your manganese doesn't get too high, because in ductile iron, it has an adverse reaction and effect on the tensils and the mechanical properties. So you want to make sure you stay below a certain manganese level. And so you're always looking for low manganese scrap for that. And then you're constantly putting carbon into the melt via carbon razor. And it just looks like, I mean, layman's terms, it looks like charcoal for the most part, or graphite. I mean, that's what it is. So you got to put it in the right proportions, and you got to put it in at the right time so it can actually go into the bath. And with iron, the furnaces are designed so that they'll stir, and they fold that carbon into the melt so it has time to actually get it mixed in there properly. Certain furnaces that are medium frequency furnaces, they don't stir as well, but certain alloys you don't want it to stir. So it just depends. A lot of steel alloys with low carbon, we're not trying to put carbon into the melt, so therefore it stirs much much more gentle than it would if you wanted it to be an iron melter, that you want it to have a little bit more aggressive stirring action, so it will draw that carbon in there, because the carbon wants to float to the top and bridge on top of the melt. So those are kind of just some of the nuances of and again, Foundry 101 and the stuff that we kind of talk about from time to time.
Nate, are you guys just using like the 50-pound bags of the graphite powder, or what are you guys adding?
So yeah, it's not necessarily powder. It's more of a lump. But we'll use some DeSelco products. I mean, there are lots of different type of products where you get them from Miller and Company or DeSelco or whoever. So it just depends on the application.
Sure.
Or what furnaces that you're using, depending on how much they stir. So yeah, you can use the powder, but in my career, I've never seen anybody use powder form for graphite. It's always been some sort of a lump. It could be 3/8 by down or whatever. But yeah, that's typically how you bring the carbon up into spec.
How high a carbon are you guys typically pouring? Like, what's your highest carbon alloy that you guys will pour?
The gray irons and ductile irons, I'd be lying to you if I told you right off the top of my head. I don't have it off the top of my head, but like at Kansas Castings, I mean, you're in the, what are you, 4%, 4.25, somewhere in there. And somebody will correct me as well. I don't have that memorized off the top of my head. I would go use a cheat sheet if I was on the melt deck. Fortunately, we have a great team that those guys do.
Yeah,
that stuff,
they know,
which is outstanding. I love it. But I do have a cheat sheet that I use for that sort of thing. So it definitely helps. The other thing, so this little card, I don't know, that's kind of glaring. This card that you sent to me, and you sent me several of them. I use this thing all the time. So thank you. And for most people, they probably can't see it, but it's got chemistry information on it. You slide this up to whatever alloy you're dealing with, and it gives you the chemistry. It's so helpful. It's so speedy, and it's so thank you for that.
Good.
It's awesome.
Good.
I think I've been you sent me one. This is the 2019 version.
Okay.
I think I had one that was like a 2010. It was a blue and gray version that I had, but I think maybe some stuff had changed and updated. So yeah, pretty cool. I think I've been using that since 2010 when I think we got to know each other way back when I was working at CFM Corporation, when we would buy some stainless from you guys from time to time.
Good. I'm glad that's working out. So
Yeah, pretty helpful. I wish I had one for iron and aluminum and bronze and everything else, but I don't. So if you want to make one, you can send me one.
Get your marketing team to generate some collateral for you, and
yeah. We'll have to get that in front of the board and see if we can get that in the budget for next year's. And yeah,
Yeah, I don't know that would pay off as well as this one has.
Yeah.
That's for sure. But
but that's
yeah,
kind of
fun stuff.
the spiel with the AOD. Really, I believe it was designed to make low cost, low carbon stainless steels. And that's really its kind of claim to fame. VOD is a little different. VOD is the same basic idea. It's vacuum, oxygen, decarburization. Kind of does the same as an AOD, just in a different way. And it's a little bit less violent. It's a little bit more, it's a slower process, a little bit more under control, a little bit more calm. And that's where we're producing a lot of our, the cobalt-based alloys or the nickel-based alloys that we're making.
so when you do
So go ahead.
when you do AOD and you're using argon, is this something you're bubbling through the metal, or is this something that it's just kind of like the environment that the metal is melting in, and so you don't have a bunch of oxygen in there? What? And then with the vacuum, how does that work? Nate mentioned, you guys mentioned that carbon wants to float. Is that how does it float because of the vacuum? What is?
So with the argon, we're bubbling argon through the bath, through the molten metal, and that's helping to float impurities up into the slag. So the slag cover is on top, and that's kind of protecting the alloy as well, protecting that molten bath from the environment, from the atmosphere. And then we will bubble argon. It's an inert gas, so it's not going to react with any of the elements. It's going to remain, but it will just help float some of these oxides and some of these impurities up into the slag. And then with so that's AOD, VOD, but they're both throwing oxygen at it. The AOD is pumping oxygen at it in pretty large quantities, and that's to help get, remove carbon, right? That's going to remove your carbons. It's going to get your low leads, your sulfurs, your bismuths, some of the unwanteds that you don't want in your final product. That's going to help oxidize those, get them up into the slag, take them out of the bath.
So with iron, I assume the slag, then the oxidized iron is lighter than the non-oxidized iron. Is that the case?
Yeah, the chrome, silicon, manganese. So it's all that's going to react and all that's going to oxidize, and that'll all float up into the slag. That'll all become part of the slag.
All right, so I'm going to ask another stupid question. How do you deliver the gas into the metal? Is it I assume you're not running a metal pipe down there with holes in it, because that'd just melt. Is it a ceramic delivery? How do you get the oxygen in there?
So that there is like a porous plug that is more of like a ceramic deal. But yeah, after that, it's hoses hooked up, and it's on the outside of the vessel as well. So the vessel, once you got the brick on there, it's going to be a couple feet thick. So it's going to be kind of well insulated, and it's just some heat resistant tubing and things like that deliver the gases. But yeah, that's from what I understand, it's kind of like cryogenic gases, right? It's huge tanks of gases on premises.
The gas just has enough pressure that it keeps the metal from running back into the tubes. The gas is just pushing.
Yeah, it's a pressurized
the metal
system
out of the tube.
Yeah, I'm sure it's a pressurized system. It's because that was one of the things with COVID. When COVID was hitting, we couldn't get industrial gases. We were kind of on the outside looking in. Our supplier declared force majeure, and they were delivering all the industrial, quote unquote, industrial gases to hospitals. So hospitals ate first, and we were kind of on the outside looking in.
That's tough.
Yeah.
So you're treating with AOD refinement. 40,000 pounds, 20 tons of material at a time. That just to be able to support and hold that is incredible. And then when you're introducing argon, which is inert, and then oxygen, which kind of dangerous, right? That's kind of crazy to even think that you're bubbling oxygen through molten metal, fire, and oxygen. That's wild. And again, the reaction with that obviously it creates agitation, and that's what helps bubble the carbon out of the melt. So you fully expect that, and it's probably the most efficient way of doing that. But man, that's got to be a sight to see.
It's like fireworks. I mean, it's pretty violent coming out of the top. That's part of the difference between the AOD and the VOD. So the AOD, it gets pretty violent, and its sparks are flying, and there's metal popping and dropping everywhere. So you steer clear. The VOD is similar but different, right? So the VOD is we tap out of the furnace into a ladle, and then a hood comes down on top of it, and that's the reaction chamber. So that's where we're going to pull the vacuum. We can bubble the argon. We can blow oxygen at it, but it can't get violent. It has to stay calm and under control. Or what happens is you seal that hood onto the vessel, and then you're in trouble. So it has to be gentle blows of oxygen, gently bubbling the argon. It can't get too violent and out of control.
That sounds insane.
It does. I'm thinking the same thing.
Yeah.
I mean, who in God's name thought that was a good idea to try that to begin with? That is just.
I don't know. It's a good question too. I don't know where the first one came from or why it was invented, but yeah, the VOD. I think there's only a handful of VODs here in the States. I could be wrong on that, but AOD is definitely the much more common method.
Well, and so the Bessemer system, I mean, when they came up with that originally, I mean, I guess it probably evolved from that type of a system to get carbon out of iron to create steel. So, I mean, it's really interesting. I bet so Sarah Jordan, I don't know if you're friends with her or connected with her on LinkedIn, but she's got a Metallurgy Monday, and she does some stuff. So she always puts really interesting stuff out that she researches, which is pretty cool. She probably even has something on the Bessemer system and AOD and VOD refinement. But
say Sarah Jordan?
Yeah, Sarah Jordan. Yeah, she's a shout out to Sarah. She's a trip. She is for being in the foundry business and that sort of thing. They're actually building a foundry from scratch. It's pretty interesting, but yeah, they're pretty cool. So she's always putting information out, which we're going to try to have her on the podcast at some point here in the near future. But
oh, good.
Yeah, pretty fun stuff. It's always fun to link, people, birds of a feather, and people that have lots of cool knowledge and they just kind of nerd out when it comes to metal and things that we do with metal. I mean, we are just kind of a unique individual, so it's not for everybody, that's for sure.
Right. Is Sarah, is she down in Texas as well? I'm totally not familiar with her. I'll have to look her up.
No, they're northeast, I believe.
Okay.
Why do I not know where they're at? Because I mean, they're building that foundry. So I should know that off the top of my head, and I don't. Yeah, well, I'll have to find out.
I'll look into it.
But yeah, when it comes to the Bessemer system, and of course, I think this is probably a step forward in that regard. So, do all metals? So if it's a low carbon steel, for example, like a 4140 or anything like that, I'm assuming you don't have to do AOD refinement for like a WCB carbon steel,
right?
Even though the carbon is still low.
Yeah, they can still do some refining, right? So if they can remove the leads, if it has to be low sulfur, for example, we'll do that, or low nitrogen, low oxygen, we'll have to obviously refine it. And they can add back carbon and tweak the chemistry and make corrections to bring it into spec, but it would go through some form of a refining step. We have skipped refining completely on 4140s and 8620s. Those aren't great items for us to produce. There's just no alloy content in there, so the ingots don't look great. And honestly, I can buy 8620 bar on the secondary market, and that's going to fit your casting needs too. Okay, cool. So,
when it comes to some of those other steels, I mean, are there reasons for you to not produce certain quantities or certain types of alloys? And like a WCB, it tends to be a little bit faster freezing alloy.
Okay.
Once you take it from the furnaces, I'm assuming it's a channel furnace or arc furnace that you guys are using to melt and hold, and it goes into the AOD refinement vessel. it's losing temperature the whole time. And as you said, the walls could be, a couple feet thick, so that it doesn't lose temperature as fast, but it's still losing temperature.
Yes.
And so is there a certain amount of time that it takes to actually refine it, or they're constantly checking it while they're refining it so they can get it out of there as quick as they possibly can to go pour it?
Well, they will check temperature. So for the AOD, just to go back, so we're actually melting in induction furnaces. So it's one large vessel. It's like a 45,000 pound AOD vessel. We've got several furnaces. We can melt in on all these furnaces, and then we just tap into the AOD. And once you've got, 20, 30,000 pounds in the AOD, we can throw raw materials into the AOD, and that's gonna melt. There's no auxiliary heat, right? We're not pumping gas into it to keep flame on it or anything like that. But they will use fuel. So they'll use ferrotitanium, ferroaluminum, ferrosilicon, all of that. They'll throw that in the AOD vessel. It'll burn it off, and that'll keep the temperature up. So they can really, once it's molten and in the AOD vessel, they can kind of keep it up to temperature for a long time. They just keep throwing ferrosilicon, ferroaluminum in there, and that's going to keep that'll keep it's going to burn right off and keep the temperature going, keep the temperature up.
So you keep an exothermic reaction to keep it hot.
Correct.
Okay, that's interesting. Okay, I learned something new.
Yeah,
the things that we don't do as a sand casting foundry or investment casting foundry. That's really cool.
And that's also one of the differences with the VOD. So in the VOD, the hood comes down. We're refining it. But once we pull the hood off, we're not adding ferro this or ferro that to it to keep the temperature up. We're losing temperature from the moment we say go. So that's a little bit more of a race against the clock, so to speak.
Which brings me to another question. So on VOD, and if you don't know, just say, hey, you're a goober. Don't ask.
He's a sales guy. If he doesn't know, just make it up. Come on.
I'll make it up. Yeah. Chances are you guys don't know it either. So
that's right. We won't know the difference.
Baffle him with BS. So on a VOD, how in God's name do you create a vacuum and seal off? I mean, we're talking about a ladle that you've got, and you've got a vessel that comes down to seal. How do you actually get it to seal to actually be able to pull a vacuum on it? You would think there would be leaks and everything else. Does the vacuum pump just overcome any leaks that might exist?
So it's a partial pressure vacuum. It's a partial vacuum system. So it's not to be a replacement for proper vacuum melt, for proper melt done under a full vacuum. But it just drives the reaction. So it's the oxygen pump going over the top just blows across, and that pulls everything out of there. And that's what helps drive the vacuum. So it's not a full vacuum.
Okay.
But yeah.
So it's a heavy vacuum that's actually helping pull all that out and at a much lower pressure. Okay. That makes more sense.
Yeah. Yeah. And there is a hood that comes down, and there's a little rubber ring seal that gets replaced like every melt, I think, because it kind of just burns itself up. But we measure the vacuum, and the vacuum's actually gotten stronger over the years. So we've upgraded, fine-tuned our vacuum system, and it works. I don't understand the science behind it either, but it works.
Yeah, you would think that there would be no way they could pull a vacuum. How in the world would you do that without some sort of a resilient seal of some sort? But yeah, hey man, my wife would say all of that is useless information. Why are you even asking?
That's fascinating. That's why.
That's what we're here for, right? To ask the questions.
Yeah, for sure.
Yeah. So and you mentioned to me earlier, in fact, it's on your website. You talk about bottom pouring, right? And are you bottom pouring out of these AOD and VOD vessels? Is that it? Where that's coming out of, or?
So yeah, we do actually. Our for the VOD, for example, it looks like a big bowl, right? So it's a big bowl. Hot metal crane takes it over, and so there's a slide gate on the bottom. So that slide gate opens up, and then it just starts filling or releasing the metal from underneath the ladle. So is
that all done remotely so that there's no personnel close to it? There's no guy over there pulling a lever so that the slide gate can open. It's all done remotely.
Yeah, kind of, but there's a guy there anyway. So it's like a pneumatic. It's a pneumatic system, and every now and again that it'll just kind of get jammed up. So he's got to
Yeah.
sit there with a long tube and kind of poke at it until the
Sure.
starts to go.
Yeah.
It always
Interesting.
amazed
I
me every
love
time I go down to the facility, just how manual and physical it is. You think that you just be able to kind of come in and flip some switches and the equipment does all the work. And it will to some degree, but there's a lot of people involved doing a lot of heavy manual physical
Sure.
stuff.
Yeah, a lot of expertise and yeah, I'm sure the team is really, really good at what they do.
Yeah.
That's awesome.
Yeah, it's a good experienced team. I think some guys have been there, longer than me, 20 plus years.
Yeah. Okay.
Yeah.
So now, do you guys only sell in the U.S. or do you sell worldwide to other foreign countries or?
Yeah, we sell all over the globe. So, every year we have a rep outfit in Europe that we sell through. All right. So they've got somebody that speaks Spanish and German and Italian and French. And we don't internally, but they do. And then we have a division, Remelt Sources Japan. It kind of acts like a trading company, so to speak. It brings Western products into Japan to sell to the foundries there. But yeah, other than that, yeah, you name it, we're trying to sell to them.
Okay.
All over the.
So the facility where you're doing all the melting and the refining and I'm assuming most of this stuff is done with extruding machines and for bar and that sort of thing. You're not just pouring it into open ingot molds and things like that.
No, we
or
are.
you do both.
We do both, yeah. So we at our facility in South Carolina, that's the VOD setup. We're doing ingot, right? So we're hand pouring molten metal into actual individual ingot molds. Those are all hand poured. So that's why sometimes you'll get ingots that might be this thick, and sometimes they might be that thick. They're all just hand poured. And then we have a continuous cast bar setup as well. So that'll produce 3-inch or 4-inch diameter continuous cast bar, one continuous strand that we'll have to, cut up along the way. And then from there we'll shear it into, 15-inch lengths for you. So you can be hand loaded at your facility. But yeah, it's a little bit of both. We're hand pouring ingots and we're producing, very specific diameter bar.
Interesting.
Yeah. It just depends.
Do any of the bars? Sure. Any of the bars are you guys selling extruded bar as well as a product that you sell, or it's mainly just all for remelt type applications?
It's all for remelt applications, but some of it would be the bar. We are absolutely selling bar for remelt. It wouldn't be. It's not suitable for machining. It's not suitable for forging. It's not of wrought structure. Perry. It's definitely just cast product, just produced in a bar form.
Okay. Yeah, I'm assuming it's just because it's more efficient and you can produce it at a much more cost-effective manner.
Yeah, it's a high-quality product, right? So when you're hand pouring, it's just like what we talked about earlier, like the turbulence, right? So when you're hand pouring ingots into the mold, there's splashing and you're incorporating gases in there and it's entrapped inclusions, if you will. When it's a bar, it's just coming out nice, smooth, steady, easy, and there's none of that. So it's a premium product. And part of the,
which is what we expect in the market.
Yeah, right. It's what the market kind of demands. One of the big areas of growth for us was medical implants, or your hips and knees, things like that. And that market really, you're not getting in there with the ingot. It had to be continuous cast bar. It's just a premium product, and that's what they demanded. So that's why we installed that equipment to go after that piece of that market.
Okay. Interesting.
Yeah, quality is a premium there, and that's what they determined they needed.
So, are you only doing the ferrous type materials, or do you guys also produce some materials that are like copper-based alloys or non-ferrous type materials?
So we work with Federal Metal, actually. So I know you guys work pretty closely with them. Most of our customers are stainless steel or nickel and cobalt based guys, and they dabble in a little bit of aluminum ingot or a little bit of copper based ingot. So we don't produce aluminum ingot, we don't produce copper based ingot ourselves, but we partner with a couple of companies that are good at what they do. One of them being Federal Metal. So anytime one of my customers needs, 2,000 pounds of C876, I go Mike Ficchetti, and he gets me a price, and they ship it to us, and we supply the customer.
Yeah, Federal Metal Company is a class act.
They are. They're great.
Amazing company.
Yeah. Yeah, great people.
Well, that is.
Okay, so I'm going to go back to the dummy mode again. I'm just sitting here. I'm sitting here thinking about how do you do that? You're talking about continuous, what you call it, continuous
Gas bar.
continuous tube.
Yeah.
I mean, it's not a tube. I guess it's not hollow, but it's. So I mean, in my mind, I'm thinking, okay, you're going from a pool of molten liquid metal. You're running that out through your and I assume it's. I mean, my experience has been extrusion. I've done rubber extrusion.
Okay.
Like 150 years ago at a job I had, but is this metal coming out? Is it cooling? What? And then you're just when it gets to a certain something, you chop it off and stack it, and it just keeps coming out. What is it? What does that process look like?
It's a lot to describe. I wish I could show you some visuals here.
Use your hands.
Yeah, just the hands. So furnace melts. We melt into the furnace. We tap into the ladle, right? The hood comes down. The VOD hood comes down. We melt it. We refine it. We've got the nice slag cover on top. It's fully protecting the alley. We hot metal crane, pick that ladle up, take it all the way across the plant, open up the slide gate over a ton dish, fill up the ton dish, right? So we're pouring out of the bottom of the ladle into the ton dish. And then literally you'll see this glowing red hot bar, right? Start to pull out, and it'll go 2 steps forward, 1 step back, 2 steps forward, 1 step back, 2 steps forward, 1 step back. And it's just creating a shell on the inside. It's like a fire hose, right? On the inside of that metal, it's still molten. It's just creating a solid shell a little bit at a time, literally like 2 inches, like just go back, go back, go back for 10,000 pounds, and it'll take about an hour to fully cast it, depending, plus minus. And then, every 20 feet or so, there's a plasma torch that'll come decouple this bar from the rest of the pole, and that'll go downstream and go off to a roller. And then meanwhile, though, that bar is still pulling the whole way. Decouple it at 20 feet, more bar keeps coming out until the whole melt or the whole cast is finished. And then even while it's still kind of glowing red hot, we take it over to a shear that can obviously stand the temperature and just start cutting these things off into 15-inch lengths while it's still glowing red hot. It's neat. It's something to see if you guys ever have a reason to go to South Carolina. Open door policy. We'd love to have you guys down there.
I have a reason to be there, so I can go check this out.
Yeah,
this is freaking phenomenal.
I know. It sounds like I would love to see this.
Yeah, they have golf courses down there too, Nate. So
I'll bring my golf club. I'll bring my Oklahoma putter.
Yeah.
So just to help paint a picture for the listener and the people viewing is, so where it comes in a couple inches and goes back out, that's all done outside of the vessel that's holding the molten metal.
Correct.
And it's water cooled, I'm assuming, and that's how you drive the solidification to create the shell so that it actually has some structure. And then you've got the cooling bar in front of it that's solid so that it can't just run metal out the bottom.
Yeah.
My question is, once you shear that off, how do you ever get it started to begin with? Because it's liquid. There's nothing there. Is there a plate that comes against that to get it started?
Yeah.
The plate comes away and then it starts going?
Yeah. So there's like a dummy bar, right? There's just and you're correct. It's not, the bar isn't being pushed out of it. It's being pulled from the outside. So there's an external puller that is constantly, pulling the bar, pushing it, pulling the bar, pushing it, pulling the bar, pushing it. And, after, I don't know, 8, 10, 12 feet, who knows? It's a solid bar at that point. But coming right out of the mold, it's not
Squishy.
Yeah, it's gonna be soft. Yep.
That is so cool.
And it's all
I could just nerd out on stuff like that all day.
It's all temperature, it's all speeds and feeds, right? It's every alloy is going to behave different. So some alloys we cast, some we don't. Some we just have never even tried it. And, there's a cost benefit analysis they'd have to do to see, is it worth trying to cast this grade, I should say. No, then we'll just stick with ingot.
Sure.
But yeah, we've had it where, you pull the bar too fast and all of a sudden, oh, now you got molten metal running everywhere, or you don't pull it fast enough and then it freezes and now it's solid in the mold and you can't get it. You're just done pulling.
Oh, no.
So now you got a whole 10,000 pound vat of metal that's not going anywhere. So yeah.
Well, okay, so dumb question. What do you do in that case? I mean, you can't just vacuum it back out.
No, you have to, you just let it set up and then you got to, strip it out of the ton dish and, cut it up or put it back into the furnace eventually.
Oh, Lord, that sounds awful.
So it's worse, I think, when you pull it too fast and you got molten metal running everywhere. I think that's the worst of the two evils, but
Really?
yeah.
Well, you're talking, how much did you say? 4,000 or 40,000?
Well, it'd be 10,000. So the VOD system, it's a 10,000 pound furnace. So you can put 10,000 pounds of bar, or you can pour 10,000 pounds of molten metal on the floor. Either.
Yeah, that sounds like a lot of metal.
It's a lot.
Me.
Yeah.
10,000 pounds of metal.
Yeah.
But I also know that when cement trucks freeze up, it's a real pain. I mean, it's a big deal to get that stuff cleaned apart.
Right. Yeah. It's nobody's happy about that. So yeah.
Yeah.
When we have a freeze off or something, it's usually a pretty big to do. And then it just leaves us with a big slug of metal. We've recovered the metal, right? We're getting the metal back, but it's unusable. We got to cut it up, slice it and dice it just to be able to put it back into the furnace. So it's not easy to deal with.
Well, hopefully that doesn't happen today, since the company was founded in 1982.
Right.
Hopefully that they've kind of got that dialed in.
Well, we've only been continuously casting for about 15 of those years. So, but you're right. Yeah, it's like, knock on wood, right? The bulk of our learning curve has already happened. We're pretty good at what we do, and those events rarely happen anymore. But there was a time when they were pretty good.
Bob's on vacation. Oh, great. We screwed it up. Let Bob know that we just screwed that up.
Yeah.
It'll be ready to run when he gets back from vacation.
Right. Let him know he's going to have a mess to clean up when he comes back to work. Yeah.
Yeah, that always makes things nice.
Yeah.
That is super, super cool. And so out of curiosity, because of being an entrepreneur and being in business, who founded the company and who started it? If it started in 82, I mean, that's not that long ago in business terms.
Right.
Who in the world in their right mind decided, I'm going to start this company? And I mean, I can only imagine the pile of cash it would take to even attempt to think about that.
Well, it started, like you said, it's 40 years old, right? But it started pretty modestly, right? Out of a guy named Jack out of his garage. And he was just buying scrap and then selling scrap. He was brokering scrap from a generator to a foundry. And then he grew that into eventually going, well, maybe I could have this foundry make a heat of ingot for me, a certified heat of ingot, and then I'll try to sell that into the market. And then eventually, they bought a building and was just kind of a middleman, right? Just buying stuff from this generator and selling it, into these various foundries. But he had a building and he had inventory. And then, maybe 25 years ago, that's when they bought the facility in South Carolina. So that was the point in time where we could control our own production. Before that, we were just relying on other foundries to make ingot for us, or just buying large parcels of scrap, breaking them up into smaller chunks and selling them, onesie, twosie drums at a time. So, and even then when we had the mill, it was pretty rough, right? It was just not, it's nowhere near what it is today. I mean, it was just a couple of furnaces and an ingot line. And we really invested a lot of money and upgrades into this mill to make it what it is today. But yeah, I'm sure it took a pile of cash at some point in time, but it wasn't all at once. We didn't do it. Rome wasn't built in a day, and he didn't build this all in one.
Sure. So this facility that you're at currently, it was already an operational facility that Remelt just acquired and then kind of rolled it into what you guys do today and made it fit your needs.
Correct. So
Okay.
I've heard a number of stories. I guess it was an ELG mill. So I think ELG built the mill,
Okay.
but it was like a plate mill. It was like to roll plate, like a 316 stainless plate mill or something like that. So it was a mill. It wasn't, I don't believe it was operational when we bought it. I think it had been shuttered for some time. And then we kind of took that mill and converted it into what we do today.
Okay. And so Remelt Sources is actually a privately held company?
Yes.
Okay.
Yeah, family owned today.
Fun.
So second generation, Brendan. So Jack started it. His son Brendan's kind of really taken the reins. There's a board, right? There's investors and a board and things like that. But Brendan's really, he's the president. He's the CEO. He's
okay.
Yeah, he's the next generation.
And are there other generations coming up in the line to continue to make sure that remains the privately held company?
There could be. I mean, yeah, Brendan has kids, and I'm not sure they're younger. I'm not sure their interest level in the business, but they exist, and hopefully it will stay a family run company.
That's awesome. I love hearing that.
Yeah, I do too. You know. So, and great people. I mean, I couldn't speak highly enough of that family and what they've done and just how they take care of their employees. It's really nice to work at a company like that.
Yeah, for sure. And that's what it takes to take care of the team and to make things thrive and continue to move forward. It doesn't happen by happenstance, that's for sure.
Right. Absolutely.
Cool.
Yeah, it's kind of interesting to hear the origin story is, I mean, it reminiscent of, and we talked about Federal Metal. I mean, he talked about, the owner starting in a garage.
Yeah.
And making ingots and seeing a need and growing the business. And it's kind of a similar deal.
Yeah.
And then also family owned and run. And I just can't get over how many people we've talked to. And it's a great place to work. I keep hearing this, it's a great place to work. And man, it's just so different than the world I came out of. So different than the world I came out of.
You're driving thousands of people away from
I know.
Well,
you know what? Good. I don't know that I've ever mentioned my previous employer's name, but you got tens of thousands of employees and you're nobody. I mean, I'm face it, you're nobody.
Yeah.
And to have a family-owned business where people keep saying it's a great place to work, I'm thinking, man, I missed out. 40 years of labor, and
the company that I came from was a really large company. There were 40 inside salespeople. It was a global company. And you were just one cog in the wheel. And then coming here to Remelt, it was really interesting because, if you made a suggestion or said something, it was the owner, Jack. My office is right next to Jack's. He's the guy who owned the company. He started the company. He would listen to me and he would take note. And then we'd talk about these things. You felt like you had more of an input to it. You felt like you had more say in what goes on or how this should go on. And I really enjoyed it. I felt like they gave me a lot of freedom and flexibility to kind of do what I thought we should do.
Yeah.
And
That's awesome.
It's been a great place to work.
Well,
so Federal Metal, that's the Naguskis. Is that who are they still?
Yep.
So they're still owning it? Okay, good.
They do.
Good.
Yep. And Chris, I don't know if he was looking for a raise or what, but he sung praises like you wouldn't believe. I'm just giving Chris a hard time because he's a great guy, but no, it had nothing to do with that. But needling more than anything. But yeah, no, it's amazing, and a lot of these small foundries are the same way. I mean, I've only worked for small corporations or worked for myself, and so it's one of those things where you kind of create the environment that you want to work in and work from. So some of the things that Perry relates to is I've never dealt with, because I've dealt with, I mean, I work for the Keiss family that owns Keiss Industries and owns CFM Corporation in Blackwell. Great family, great values, faith-based company, privately held company. I mean, you couldn't ask for better people to work for.
Yeah.
I nothing but high regards for all of those guys, the whole Keiss family, and amazing. So yeah, the good thing is I don't know that I ever had to work for really bad owners or bad bosses. So I didn't really get that experience. Sure, people have character flaws and character traits, and we all do, myself included. But for the most part, you take the good character traits that they have, and you kind of plug those in, and all the bad ones, you kind of throw those in the bin,
Right.
and try to model what other people have done and led in certain ways. Unfortunately, when you're in the trenches, and we've talked about this in the past, when you're in the trenches, you're out making castings, that sort of thing. You don't really have time to get away from the plant because you need to be making castings. So you don't get to get technically all the leadership that you probably could benefit from, and that's some of the stuff that we're trying to incorporate with the foundries that we own now, which is, it's more difficult because you still have the same limitations. You still have to be able to produce castings and get them clean and get them shipped out the door so you can invoice for them.
Right.
You have to do all of those things. So I think that you're seeing I don't want to call it a renaissance really, but there's enough of us younger people and entrepreneurs that are in the foundry industry that are kind of taking the a different approach to what we've seen, what I would say, quote unquote, old school foundry mentality and things that they do. I mean, we grasp onto technology. We're using 3D printing technology. We're using solidification and flow analysis to simulate everything on the computer so that we can actually see what's going on. Yeah, it's theoretical, and people will say that crap doesn't work. But again, it's garbage in, garbage out. If you take the time to go and walk it back, and when you do have a defect and see what happened and give the information of pour times and temperatures and all of what you did in reality, it does work. But you have to work the system. You have to work it properly and use it as a tool, not necessarily just say that it just doesn't work and throw it in the bin as well. So there's a lot of people, I mean, that are in the foundry industry, and it's really exciting to see that kind of thing happening. Kind of like Dakota Foundry, for example. Corey Anderson, young guy, ambitious, works out, tries to maintain his health and that sort of thing. Great dude. I guarantee you, working for him is probably a lot of fun.
Yeah.
Is there a stress in the foundry business? Absolutely. We are squeezed from multiple sides all the time, every day. Regulations, taxes, insurance, health insurance, dental insurance, all the sort of things that you have to take care of to take care of your team and honestly your family that works for you. You want to take care of them so that you want them to better themselves as well. And a lot of times, to be quite frank, the employees have it better off than the actual owners themselves, depending on the size of the company. Why do you do that? Because they're family.
They're family.
You want to present it as that. Are we perfect? Hell no. We stub our toes from time to time, and anybody that says they don't, they're a bold-faced liar. So it's just part of life. And again, if we are really critical about ourselves and about our business and we want to grow it, customers see that. You take care of, you do the right things, you do what you say you're going to do, and you move forward. I'm probably one of the worst sales guys there are because I'm way too honest when it comes to that stuff. I'd probably be farther ahead in life if I wasn't, but it's just I can't do it. So I'll take a butt chewing over telling somebody a non-truth. So it's just part of who I am. But yeah, the foundry industry, and we say it all the time, and we're trying to let people know, this is not a dirty, bad business to be in. We are trying to recruit young, intelligent, motivated people so that we can actually grow this business rather than it shrinking like it's continued to do over my 31 years in this business. I continue to see it get smaller and smaller and smaller, and it's a little bit alarming. And we've got to reverse that trend because it is actually a fun business to be in. We get to create stuff from nothing. We get to create stuff that's functional, it's usable, and it's good for the environment for us to recycle the things that we're recycling. Yeah, we're not always taking all the scrap. We let you guys do some of that stuff, and then we take the refined stuff that is higher quality than we could ever produce ourselves to produce a very, very high quality casting for the customer. So it's fun stuff to work through. That's for sure.
Bryan, how
Yeah.
does that make you feel when he says they create something from nothing? And I assume that means you're selling nothing to him,
I'm
right? Is
selling
that kind of the way it
We're
works?
selling the
leave it to
dream, Perry.
leave it to Perry to stir the
We're
pot.
selling the dream, Perry.
I'm
That's
going to
what
pull the pin and throw the grenade in and walk out of the room.
No, I
I'll leave
like
up
it.
to
I
Perry.
really do. And it's funny. I talk about this all the time. You know, I was just on the road 2 weeks ago, just out visiting customers, and I've got a perpetual list, right? And every so often, I got to take a customer off the list and move them into the not in business column. And that column has grown, you know, for the last 15 years. It's insane at the number of customers that are just out of business. And where does that work go? I think all goes overseas. It's not in this country
Yeah.
anymore.
Yep.
There was one customer that I visited. They had at one point in time four foundries. Four foundries. They've got one left, and it's the smallest of all of them. And they're busy, but there were three other foundries that were full of work that just no longer exists anymore. So the industry has gotten decimated in the 18 years that I've watched it.
Is that largely
that's-
because of the offshoring of the work?
I think so. I had a customer in Texas, and this is kind of one of my earliest customers, really good customer. And he would say, Bryan, we've lost so many jobs to Texas. To China. We're trying to get them back, but it was just so difficult. And they were basically a captive shop for a very large company. And that large company just didn't care. They could get them cheaper in China. They had quality issues, but even what would happen then were he would tell me these stories of, yeah, they got this pallet of parts in and they were all out of spec. And they said, well, you know, the foundry in China said, just keep them, throw them away, do what you have to do. We don't want them back. We'll just send you more in spec parts. So the parts were just, you know, it didn't mean anything to China. They're just, all right, keep them. We'll send you more. And they would have to deal with that every now and again, but the costs were so low that corporate was just willing to deal with that.
Yeah. Wow.
So,
Yeah, it's sad. It's sad for sure. And the thing is, dealing with that, those companies, a lot of those companies, in my opinion, they're they're publicly traded companies. They have shareholders that they get a tremendous amount of pressure to be able to turn profits day in and day out, and year in and year out. And the quarterly, you got to make things happen, or you're on the chopping block.
yeah.
So the almighty dollar, and honestly, it's not just any one shareholder, because guess what? Any of us that are in mutual funds and everything else, we want our portfolio to grow. We want to have growth in that. So we all, myself included, we contribute to that perpetual cycle.
Mhm.
Nobody's insulated from it unless you just don't invest at all, which is I doubt that most people don't do that. I'm sure there's a percentage of the population that don't, but so we all want to see our portfolio continue to expand. So none of us are innocent. There's blood on all of our hands because we want that to happen. The thing that we need to be cognizant of, and I ran into this week, actually. So at the 4th of July, we're recording this on the 2nd. The 4th of July is in a couple days. Well, I wanted to put some flags out at my house. Well, I go to buy some flags, and I can go buy a flag for, $7.99 for a Chinese-made American flag, or I can spend $24.99 for an American-made flag. So what do? So you weigh the options. Well, that's what the American people see when they go to Walmart and Target and other places. So do we do the thing that we should do, which is buy the American-made flag? 100% that's what I did, because I want somebody to buy an American-made casting as well. So I try to support that. But is there a cost and a sacrifice to be had? 100%.
Sure.
Look at the percentage of higher price that you get with that. How the heck do they even make a flag that cheap in China? Make it in China, ship it all the way to the United States, get it in the store gets a margin.
Right.
So what was the cost of that? If let's say it's $10, did they get that flag for $5 or $4? I don't understand how they even make things as cheap as they make it. And I've seen that happen when it comes to castings. I've had off the record conversations with people, and they'll say, hey, this is what we got, the price quote we got from China, this is the price quote we got from India, and this is the prices that we're getting average from America. And holy moly, you're talking about 10x cheaper
Yeah.
from China and India. And it's like, how do they even produce that? And I said, and part of it is they'll give you the price. And so a lot of the buyers aren't actually being 100% honest, in my opinion, because what happens is they'll tell you what the price is that they're buying it from in China, in Shanghai, or wherever in India, and they're not telling you what the landed price is, and they're also not telling you if they've been buying this part, what is the scrap and how much has that cost you, because you've machined on something, you brought it in, you've shipped it over, it was scrapped, and next thing you know, you got to deal with that. There's a cost involved,
Sure.
admin cost that goes to that. I'll guarantee you they don't capture any of those costs to be able to put that to see what that dollar figure is. If they get a high quality part from the United States, they've got somebody that they can call and they get them on the phone. Or better yet, I mean, if you're in Texas and you want to buy a Texas-based casting, Texans love doing business with other Texans, and so that happens a lot. Well, guess what? Yeah, Texas is a big state, but you can still get in front of somebody. You can look them face to face,
Right.
eye to eye, and you can get something done about it. And they are an extension of your company, no matter if you're an OEM or you're just a mom and pop that has a product line or anything like that. There's an inherent benefit to that, and that people don't talk about. And the buyers that are out there buying castings typically, and I'm not being critical of buyers are doing their job, which is good for the company that they work for. Kudos to them. That's awesome. But I don't think that they're doing their company is a good job whenever they don't capture all the costs. How do you do that? Logistically, it may be a nightmare on their end. I don't know. But it's not apples for apples. There's no way.
Yeah, those are real world costs, the soft costs, and they're just not getting captured. And yeah, and that's, at the end of the day, that's what I'm trying to tell customers too, is look, you might save a few pennies a pound on the front end, but it could cost you dollars on the back end with rework and weld repair and things like that. So buy proper up front, and it could save you guys all on the back end. And, just to kind of go back on that, how does China do it? I'll tell you, we used to get these streams of scrap, and they were service parts pulled out, and we would buy them based on the nickel content. And this, is two different sizes, and this size was supposed to have about 20% nickel, and this small size was about to have, supposed to have 12% nickel content. It was some proprietary grade. We were just buying it as scrap. Well, we'd get the parts out of service, we'd test them, and the 20% nickel would have about 16.5% nickel. The 12% nickel would have about 9%. So they're way under spec on the alloy content, but they came over here from China, they put them in service, they worked, they pulled them out when they pulled them out, and then we bought them. But I just think it's just not as advertised. That's my guess, at least.
And I think you see some of that, but I don't know how they get by with the requirements, whether it's ASTM specifications or any of the other specifications that we all have to abide by, right? They're ISO certified, so they have to do what they say they're doing. They have to get audited on stuff. So that's all just a big farce if that's the case.
Yeah.
Because they're not meeting the spec. But maybe some of those are scrap because they did fall out, and the system, the ISO and all that sort of stuff, the ASTM specs are catching that. They just happen. You would think that they would want to remelt some of that stuff, and maybe it just doesn't fit their process. But yeah, it's the quality part of it is night and day different. And I would think for the customers, being able to get somebody actually on the
Yes.
phone or getting them face to face at their facility to deal with it. I mean, even in the U.S., yeah, you can jump on a plane, you can be anywhere in a day.
Right.
So I mean, if you're dealing with a manufacturer or a foundry in the U.S., it behooves them to actually do business in the U.S. The problem is that the pricing is so significant. Something that might be $4 in China might be $40 in the
Yeah.
U.S. Well, there's a $36 difference, so therefore they're going to buy them from China, even though they have fallout or whatever. So it's I don't understand all that. I wish somebody would say, "Hey, you're an idiot. This is how it is," and spell it out for me, because I don't understand how Chinese subsidies and how all that stuff works. Because that money has to come from
It's
somewhere,
coming from
right?
somewhere, right?
I know China has billions of people. What are their taxes like? I mean, the money, if the government's subsidizing it, they're having to get the money from somebody, which would be the people, or from tariffs, perhaps. I don't know. So, but how does that work? I need somebody just to explain it to me, because I'm an idiot.
Well, when you find that person, you can explain it to me after they've explained it to you, because I'm in the same boat.
Yeah, I've never figured it out, and people keep saying that, but I just have never had anybody explain it to me in a way that um, that the light bulb still is pretty dim for me.
Yeah, yeah. None of it seems like it makes sense all the way around. But are you seeing jobs come back from China? Are you seeing inquiries coming back to say, quote this, we're
Th-
here in China?
yeah, there are. Yeah, and there's a lot of quality things that are transpiring in the U.S. that people are. I mean, with the tariffs and that sort of thing. Of course, some of that, it's kind of playing itself out at this point. So it's not like you have an economic advantage in that regard. It doesn't level the playing field. So really, it from my perspective, it's a the bargaining chip. It's leverage. You keep jacking it up, and the next thing you know, they get what they want for something over here that you don't necessarily benefit manufacturers. Because I'll guarantee you give America a level playing field, we'll beat anybody in the world, without a doubt. There's not a whole lot of stuff that we can't do in America, and most of the stuff. I mean, and there's other countries, Germany and Japan and lots of places make really good product. Spain and places like that. So there are other places that produce high quality, innovative products, and typically all of them have something to do with castings to some degree. I don't care where they're at. And without us, if they keep letting us shrivel up and not giving us a level playing field, it's going to get harder and harder and harder for us to continue to do what we do in this business. But it's one of those things where I feel like it's definitely to our advantage to continue to fight the good fight, and continue to let our voices be heard. So I think it's super important for at least the foundries that are still out there
Yeah.
to make their voices heard. It's super important in my opinion.
Yeah, I agree. I agree. It's the industry has been hit pretty hard, and I think it needs, and I think it needs more
Bryan,
like
you
just
mentioned
needs
early
more
on.
people.
You mentioned
Go
early
ahead.
on that you're international, but I assume that you're not selling large quantities of product to places like China that are producing low dollar castings.
No,
You're going
China
into other
has
markets.
no. We're not really. There's not much for us in China. There's not much for us in India. Japan, Europe, some South America. Um, those are the larger areas for us. Um, yeah, I mean, China's got a alloy producers. There's nothing there for us.
Right.
There's nothing there for us.
And you guys, I mean, as far as your lab and that sort of thing, I mean, you guys have a really good lab that you guys did fairly recent development for you guys for NADCAP and that sort of thing. Is that the case, or am I mistaken?
NADCAP maybe within the last 10 years. But no,
Okay.
it's fairly newer lab equipment. I think we actually have new lab equipment on order again. So we're always trying to upgrade the lab. We're always trying to, redundancy, right? We have 2 or 3 pieces of equipment just in case one goes down. We're actually right
Hmm.
now in the middle of a plant expansion. It probably won't be up and running till sometime mid to late 26, but could be an increase of capacity up to 50%. So more furnace capacity, maybe another continuous cast line,
Wow.
and then maybe another VOD, things like that. So we're expanding. We're trying to grow the business as best we can, and we think that the business is coming back kind of to sometime in 26 is when we'll see. Hopefully all this is behind us.
Yeah. So I mean, are you guys seeing? I mean, a lot of foundries, because you sell to lots of places across the U.S. I mean, are you seeing an uptick in business this year? Because as a entrepreneur and owning a couple foundries, I mean, it's one of those things where 2025 hasn't been all that great, to be quite frank.
No, it hasn't. So my experience too, election years were always off years, right? Regardless of what was happening and where it was happening. Election years were always off years. And this election year was off from beginning to end, right? In January of 24, it seemed to really kind of slow down. Everybody was just a little bit, there was some apprehension, right? Nobody was just too excited. Nobody was buying too much. Nobody was just kind of sitting and waiting. And then the election happens, and then typically January 1, kind of back to business as usual. Well, that didn't happen this election cycle either, and then it kind of got worse with all the tariff talk and the wars. And it seems like every time you talk to people, they go, well, maybe by mid 25 it'll be maybe late 25. Now we're into 26. Hopefully, fingers crossed, things will start looking better in 26. From where I sit, every, hey, this week is busy, next week is slow, so it's really spotty. It's just nowhere like it was maybe 2 years ago. And again, I will say this, for us, 22 and 23 were really good years. So it's kind of the normal cycle of business. So it was going to slow down eventually. Then throw that with 24, and now here we are at 25, and things still aren't back to where they should be.
Okay.
So yeah, I think we're all kind of holding out for 26 to see what comes from it.
Okay. Well, and earlier in the podcast, I'd mentioned Sarah Jordan. The company and the founder that they're building is called Skuld, Skuld, and they're actually in Ohio.
Oh.
I'm not even going to try to pronounce this city. I think it's close. Piqua. Don't even ask me.
Piqua?
Pigwa?
Piqua, yeah.
Piqua. Yeah. Pigwa. Yeah. Well, whatever.
Skuld. Are they like an art foundry or something, or what does Skuld do? What are they looking
No,
to?
so they are using some lost foam. They're using 3D printed technology, some stuff like that.
Okay.
So yeah, she's one of the founders and CEO. Around the Dayton metropolitan area
Sure.
somewhere. I don't know. So anyway, it's kind of in your guys' neck of the woods, I'm guessing, right?
Yeah, absolutely. It's a couple hour drive for me.
Yeah, you have to check them out.
I will. I
and then
appreciate that. Yeah.
Yeah, you bet. They're doing some pretty innovative stuff, and she's a treat, that's for sure.
And they're up and running, or they're building it now?
So they're up and running and building at the same time. So
Okay.
they are producing some parts. But yeah, check her out on LinkedIn for sure.
Yeah, definitely. I will check it out.
All right, so Bryan, we were talking, just a second ago about the alloys that you're seeing, the castings that were coming back from China, and you were saying that you're talking about nickel, and the nickel amounts not matching what they were supposed to be doing. Do you guys? We've talked about your process a little bit, but is there more to it? Are you guys doing things to certify? How do you certify the content of your alloys?
So typically, if we're melting in, whether it's a 40,000 pound heat or a 10,000 pound heat, we're taking chemistry samples the whole way. So we're going to take it, we're going to melt in, we're going to take a chemistry, we're going to figure out what we need to tweak to bring it into spec. And then even when we're pouring ingots on a large 40,000 pound heat, we're taking stream samples. We're taking metallic samples at various times throughout the cast, and we're analyzing those samples. When we're doing a 10,000 pound heat, we're taking a beginning, a middle, and an end sample, and we're analyzing those, and then that's the average of those three. With the large 40,000 pound vessel, 40,000, we might take 7, 8, 10 samples, and just to check chemistry throughout, right? Just to make sure we're not fading in chrome, fading in silicon, something like that. And usually that like on the VOD heats, the beginning, middle, and end, the average of those is the certified value to you. That's what's going on the cert that you guys see. And we want to make sure that, the chrome doesn't start off right in the sweet spot of the range, and then by the end of the cast, it's faded and it's below spec now. We've lost chrome, manganese, silicon, something like that, and they've all faded out of spec. So we have to monitor the chemistries throughout the whole cast, basically.
And so you're doing that
equipment. I'm sorry.
You're doing that real time, right? As it's melted metal and you're pouring ingots, you're taking that sample, running it to a lab, analyzing it as they're just working then?
Yeah, they will. There's certain things that we can't, like certain elements will have to be acid digestion, and that's like a 24-hour thing. But everything else, we're taking it in real time. And honestly, if we're already in the stages of pouring ingot, we're not making chemistry adjustments. We're just monitoring it to make sure it doesn't go below spec. It's just not going to fall out of spec. Same thing
Can I ask you an unfair question then? And maybe you don't want to answer this. What sort of tolerance do you have on your specification? You talked about taking averages. What sort of tolerance do you have on the specification?
Well, I mean, there's a spec, so there's going to be a range. So if the range is, let's just use 316 and Molly, right? You got a 2 to 3% range.
Okay.
This might be a bad example because it's not.
The spec has those tolerances built into it then.
Yeah, and we won't say, so if we get a reading that's the first sample is 2.15, then the second sample is 2.8 or 2.08, and the third sample is 1.92, whole heat's out of spec. So we're not going to average it up into spec. If any one of those samples falls below or above, it's out of spec for any reason, the whole heat is considered out of spec. We'll never try to average it. Then you just get into a habit of where you're just, the more samples, the more chances we're going to have to average this thing into spec. So we don't want to get into that habit. So if we get a reading, any sample that's out of spec, the whole heat's out of spec.
Okay. Well, I'm good. I mean, all right. Well,
yeah, and in your standards, I mean, you're held to a pretty high standard when you're NADCAP certified and ISO, I don't know, 14,000 whatever. When they come in and they're checking and auditing that sort of thing. That's why that we depend on companies that are specifically certified to those standards. So and that's the reason why we buy that type of material. So we're starting with rule number one is start with good melt stock, and you know what it is. It's ultra clean, ultra good purity. So it makes our life a whole lot easier out here. We're making nothing from nothing, right? Making something from nothing, Perry.
Is that a song? Nothing from nothing.
I'm sure it is. If it's not,
yeah,
we should probably write it.
As I say, sounds like we're writing one right now. Yeah.
All right. Well, Bryan, thank you so much for joining us. I thoroughly enjoyed it again. Thank you. I appreciate you taking the time to speak with us. And you mentioned you were honored to be asked. Well, the honor was all ours. So
absolutely.
Yeah.
100%.
Thanks. Nate, you got anything else you want to?
Yeah. I mean, if there's anybody out there that has any other topics that you would like to hear us talk about, or find an expert, or maybe you're the expert and you want to be on the podcast, reach out to us, Perry at foundrytalk.com and Nate, Nate at foundrytalk.com. We'd love to hear from you guys. Maybe there's nobody out there that even listens to us. We know that's not the case. The content and the audience is building all the time, so it's a lot of fun. We thank you guys for listening, tuning in, commenting, and that sort of thing. So we're just looking for a little bit of participation. If you guys are interested about something in particular, or there's something you don't like that we do that's annoying, tell us that too. You're probably not going to hurt my feelings aneway. You might hurt Perry's feelings, but hey, he's getting much better.
I'm the
getting much thicker. But thank you guys for listening and watching and sharing and like. I don't know where you guys are listening from, because we have this thing shot out all over the place. So on YouTube and Spotify and everywhere else. So thank you guys. We appreciate it. Bryan, thank you for taking the time out of your busy day to come online and visit with us. It's a treat and an honor for sure.
My pleasure. I appreciate it. Thanks for having me, guys.
All right.
I bet you. We'll talk again soon.
Thanks.